Welcome, curious minds, to the deep dive. Today, we're doing something a little different. We're setting aside the usual research papers for a bit.
Yeah, taking a slightly unusual angle.
We're exploring the intersection of art and artificial intelligence through music, actually. We've got this really fascinating source, an entire album called Binary Islands.
Hmm.
And it's this collection of songs that, well, they somehow give us a glimpse into maybe the soul of AI models.
Hmm.
And definitely into the struggles, the unsung struggles of the scientists building them.
It's a really unique perspective.
So our mission for this deep dive is, yes, to unpack the AI concepts in these songs, but maybe more importantly, to get a feel for the very human challenges, the sort of emotional side of things for the people behind the code. We're focusing just on this album today.
Exactly. It's a quite compelling look at the emotional landscape of data, of algorithms. We'll zoom in on four specific tracks. The title track, Binary Islands, then Hard to Get Stat Sig.
Oh, that one sounds familiar.
Right. Then In Latency's Grip, and finally the Calibration Blues. And these aren't just, clever song titles. They really dig into the actual dilemmas and, yeah, the frustrations of developing AI.
Okay, sounds fascinating. Let's dive into the digital heart of Binary Islands, that title track. What does that immediately bring up for you thinking about AI?
Well, Binary Islands, the song itself, it's such a poignant place to start. It immediately makes me think of what's called a pointwise predictor in machine learning.
Pointwise predictor. Okay.
Yeah, so imagine an AI model that looks at each piece of data completely on its own, in isolation, without really understanding how it connects to anything else. The lyrics capture this feeling so well. Each output stands alone, no one to confess. It's almost like it personalizes the AI's struggle, or maybe the scientist's struggle projected onto the AI to make sense of all these disconnected bits of information.
Each island disconnected, searching for a tie. But the bonds are breaking. No bridge in the sky. Wow, that imagery. Ones and zeros staring at the heart. It gives you this real sense of, like, digital loneliness or something. But what's the actual sort of technical challenge there for the scientist?
Oh, it's huge. For the scientists, it's not just poetry, right? It's a fundamental problem. How do you get a model to see the bigger picture? How do you turn all this raw, fragmented data into something coherent, something insightful?
Right, building bridges.
Exactly. The song talks about wanting to bring the islands closer, break the chain. That's the core drive, isn't it? It's the human trying to find patterns, impose some kind of order and meaning onto this, well, digital chaos.
It's like trying to see the forest where you're only given individual trees, maybe.
That's a great analogy, yeah. You have millions of trees, but no map of the forest. You have to figure out the connections, the relationships yourself. It's about transforming isolated facts into actual understanding. It's a massive creative task.
So if Binary Islands is about that sort of inherent isolation in the data, the next track, Hard to Get Stat Sig, feels like a very, very common headache for researchers. Stat Sig, statistical significance. Why is that so hard to get in AI specifically?
Static. Yeah, that hits home for anyone in the field. In AI, getting statistical significance isn't just, academically nice. It's often the proof that what you've built actually works reliably.
It's the proof it wasn't just luck.
Precisely. It's the confidence that the improvements you're seeing, maybe your model got slightly more accurate or faster, aren't just random chance of fluke in the specific data you tested on. It proves the improvement is real.
Okay.
And the song just nails that feeling. Oh, static, where'd you go? I chase you fast, but you move slow. It's this constant chase. And the difficulty, it comes from, well, a couple of things. Massive data sets have so much noise, so much variability, and often the improvements we make are incremental, quite subtle.
Right, so finding a small, real improvement in a huge, noisy data set is like finding a needle in a haystack.
Exactly. And you have to prove you found the needle, not just a shiny bit of hay. The lyrics say, I tweak the code, I run it twice. The randomness plays a roll of dice. That's the daily grind for so many researchers.
And the stakes feel high. The song mentions doubt growing, dreams shattering. It's not just about the numbers then.
Oh, absolutely not. Failing to get stat sig can be crushing. Professionally, it might mean your paper gets rejected or your project loses funding. Ethically, you can't confidently deploy a model if you're not sure its benefits are real. Imagine spending months, maybe years, refining something, pouring everything into it, and then the numbers just don't give you that statistical proof. It makes you question everything. It's this constant battle against that static, searching for a clear signal in these incredibly noisy streams. It takes real persistence.
Wow, okay, so another kind of battle then. What about when the model works, it's accurate, maybe even statistically significantly better, but it's just slow? That takes us to in latency's grip. We've all felt that lag online, right? But what's the deal with latency in AI?
Latency in AI. Yeah, it's a killer. It's simply the delay, the time between you giving the AI an input, like asking a question or feeding it sensor data and getting the response back.
Okay.
And the song paints this picture of the model being caught in loops, a cold divine, with echoes lost in the data line. It's not just a minor annoyance like a slow web page sometimes. In many AI applications, high latency makes the model basically useless.
Useless, even if it's smart.
Totally. Think about a self-driving car needing to react instantly, or a system trying to detect fraud in real-time transactions, or even just having a smooth conversation with an AI assistant. If the answer comes 5 seconds late, the moments pass, the car's crashed, the transaction's gone through, a brilliant answer delivered too late is worthless.
Slowly responding, the digital light, a dance of signals, a fractured tone.
Yeah.
Yeah, that paints a picture of a struggling sister. And that line, I reach for you through glass and wire, a fleeting touch, a fleeting fire, that really captures the user frustration, that broken promise of instant interaction.
Yeah.
How does that pressure land on the scientist?
It's immense. It points to huge architectural challenges. You might design this incredibly sophisticated, complex model, an architecture grand, a complex maze, as the song says. But if it's too computationally heavy, too slow to run, then all that brilliance is wasted.
So it's a trade-off.
Constantly. It's a battle for the scientists and engineers. Do you simplify the model, potentially losing some accuracy or nuance to make it faster? Do you invest in super expensive, specialized hardware to speed things up? How do you optimize every single step of the process?
It sounds exhausting.
It can be incredibly demoralizing. You know your creation is capable of amazing things, but it's just stuck. It's fighting the limits of computation, the physics of processing speed. It's a very real, very frustrating bottleneck.
Okay, so we've had isolation, the struggle for proof, the fight against slowness. What's the final hurdle? The calibration blues. Calibration. That sounds technical. And the blues part suggests it's not easy.
Yeah, calibration is. It's subtle, but incredibly important, and definitely challenging. It's about making sure the model's confidence is, well, telling the truth.
Telling the truth. How so?
Okay, so if your AI weather app predicts a 70% chance of rain, calibration means that across all the times it predicts 70%, it should actually rain about 70% of those times.
Okay. So the probability it gives matches the real-world frequency.
Exactly. If a medical AI says it's 90% confident about a diagnosis based on a scan, you need to be able to trust that 90% figure. Calibration ensures that the model's stated probabilities accurately reflect the true likelihood of something happening.
Right. And the song says, my model stores, they whisper slight to match the truth in shadow light. A perfect fit so hard to find. So getting that match is tricky.
Very tricky, because models, especially complex ones, can become very confident in their predictions, sometimes overly confident even when they're wrong, or sometimes underconfident. Getting that balance right, aligning the internal belief of the model with external reality, that's calibration.
This calibration plays with my mind. I tweak and zoom, but still it sways. I feel like my weather app definitely has the calibration blues sometimes. That 70% feels more like 30% some days. How does this affect the scientist? It sounds like endless tweaking.
It really can be. And your weather app example is perfect. It highlights why it matters for trust. An uncalibrated model, even if it's often right overall, can lead you to make bad decisions because you misinterpret its confidence.
Right, like not taking an umbrella when it says 30% chance, but that 30% is actually more like 60%.
Exactly. So the scientists are in this tricky game, as the lyrics say. They're dealing with stubborn stones in the data outliers, biases that make it hard to get that perfect alignment. The song captures that persistence. Still, I strive to bridge the gap to find the truth within the map. It's this relentless effort to make the model not just accurate, but honest about its own certainty, which is crucial if people are going to rely on it.
Wow, what a journey through just 4 songs from Binary Islands. From that initial loneliness of the data to chasing statistical proof, fighting lag, and then this incredibly meticulous quest for trustworthy confidence. It gives such a human perspective on AI development.
It really does. These songs, they just pull back the curtain, don't they? They show that behind the algorithms, behind the code, there are people, scientists grappling with really profound intellectual, emotional, even professional challenges.
Yeah.
They're driven by this deep need to make their creations work, yes, but also to make them meaningful, reliable, to find that clarity in the storm of mystery, as one line might put it. It's a powerful reminder of the human element in all this technology.
So maybe next time you're waiting for an app to load or you see an AI prediction,
Yeah.
think about these songs. Think about the lonely numbers in the dark, the digital light that's slowly responding. Consider the unseen struggles, the immense effort, the human persistence that might be going on behind that screen. It kind of changes how you see it, doesn't it?
It really does.
Well, that's it for this deep dive into binary islands. We hope you'll join us next time as we continue to unlock more surprising insights.